Great, so as Rob sets up, so I'm Carl Kesselman. I'm the PI along with Yang for FaceBase now for, actually we've been doing this for 10 years. FaceBase has got a really kind of interesting and wonderful structure that it's a very close collaboration between the group at the Information Sciences Institute at USC and the dental school at USC. And so we represent more of the kind of the software engineering, computer science side of the puzzle. Of course, we work together very closely almost every day we're talking. And so what we're going to hear now is Rob Schuler, who is the technical lead for FaceBase, and there's a number of other really dedicated computer scientists who are involved in this, and some of them, Alejandro and Laura, sitting in the room here. And Rob is going to summarize kind of the main accomplishments and some of the future directions that we've seen over the past 5 years in the transition to FaceBase 3, and looking forward to the future, and also hitting on some of the points that were brought up in that very enlightening talk we just heard. So with that, Rob Schuler will give us a review of what's going on.
Okay, thank you. Yeah, it's my pleasure to share with you our year-end review and our future plans. So as Yang shared in his introductory remarks, FaceBase has a mission to serve as the trusted online data resource for craniofacial and dental researchers worldwide. And as was noted, FaceBase has grown over the first, second, and third phases from a narrow developmental focus on maxillomandible to a developmental focus on the whole craniofacial complex, to now in the third phase of FaceBase, a more expansive mandate to support all dental, oral, craniofacial, and related research across the translational spectrum. And also, as was pointed out in the introductory remarks, FaceBase has a strong community of data contributors and serves a worldwide user community. Our data span imaging, sequencing, and a variety of other assay types. We see an average, in an average year, 16,000 or more unique visitors to the site. So unlike most of our past meetings, today we wanted to share with you a 5-year review to take a look at how the community has grown over the past phase of FaceBase. To put things in context here, we should note that as FaceBase 3 was a major transition point. FaceBase 1 and 2, as Yang mentioned, were organized in a hub and spoke model, where spoke projects were funded for 5 years along with the hub to produce and contribute data, and mandated to do so before publication even. At FaceBase 3, however, it was organized as a hub-only effort, and so gone are the spoke projects and the guaranteed data contributors. So this raised some serious questions here. Would the community contribute data? Would they curate high-quality data? So fortunately, I won't keep you in suspense. Fortunately, the answer to both of those was a robust yes to both questions. We marked here, if you can see it, with a red asterisk on the timeline of approximately where FaceBase 3 began. So at the top left, you can see project growth, which is a measure of new research groups that have contributed data through FaceBase. So in the past 5 years, we have added over 30 new contributing groups. So you can, that one doesn't go all the way down to 0, probably there goes to about 20. So that's where we were at. Of course, with FaceBase 1 and 2, we had a built-in 10 spoke projects each. So we've really expanded the contributors. Below it is data set growth, and that shows a trend line that really does not slow down from the pre-FaceBase 3 phase. And then on the right are 2 key measures of data growth for imaging and sequencing. In these cases, we have seen either a continuation of the trend or a significant spike. And then finally, the bottom center shows metadata. And you can view this as an answer to that second question about whether we would have high quality data, because this represents the careful organization and annotation of data in FaceBase. And overall, very positive indicators of continued contributions to FaceBase. Okay, and then we do want to give a year 5 review as well. So this kind of focuses in on our most recent year. So we're about 3/4 of the way or so through year 5, and we've seen 90 new data sets that are either released, are embargoed, or are in progress right now. 59 are already out in public. And this includes, you can see on the right-hand side, a wide variety of assays across human subjects and animal models, and also a sizable collection of human subjects data. Okay, another thing is over the past 5 years, space-based data have also become increasingly diverse. So the figures at the top from left to right show a sampling of statistics about the growth in biological characteristics and experimental or assay types related to the data deposited in FaceBase. Both figures indicate that FaceBase has seen many new categories of data, and in a sense, have filled in the gaps in the overall collection. And then at bottom are just some thumbnails there that indicate a sampling of the data types that are in FaceBase. A few of them are marked with new, where as of FaceBase 3, they're either largely or completely new categories of data that are now available in FaceBase. Okay, and then in terms of data usage, we can also see an overall positive trend across a variety of measures here. On the top left, what you see are registered users, and below that, the actual online visitors to the site. Both show strong activity from the user community. And just note that the stats for year 5 are incomplete. We take these measures at about the mid-year point and the full year point. On the right-hand side are online image views and visualizations, genomic track reads through our integrated genome browser. So a lot of activity on FaceBase is not only coming and getting the data and taking it for offline analysis, but spending time on the site with the images, the image viewers, the track visualization tools. And then finally, at the bottom middle, what I'd like to point out is that data downloads have steadily grown. Even if you take out the spike we had in year 3, which was a great thing, but it was largely due to a large data collection, which is a tremendous resource of images on mouse development. And we often see like an increase of download of new data, say after it's been first released and the publication goes out. But even if we didn't have that nice spike there in year 3, if you look at the overall trend line, it's been very, very positive. So I mentioned that we take these measures at about the half year and full year mark, and a preview of year 5. We're again about 3/4 of the way, and we actually have seen over 28,000 downloads so far. So we're going to have a significant growth in this year as well. And if you compare back to our FaceBase 2 timeframe, even 1,000 file downloads at that point was considered a very good accomplishment. So today we're seeing that many in a given month or more. Okay, and so next we wanted to give you a little bit of the behind-the-scenes approach to FaceBase. So first of all, FaceBase is built on a sophisticated platform to support fair, findable, accessible, interoperable, reusable research data. So FAIR data guidelines were defined by an international community to clarify best practices for handling research data. So when you're considering a repository to submit your data to, this is among the key characteristics that are used to decide whether this is a good fit, a good choice of a repository. FaceBase has been one of the main contributors to the open source software platform that we call Deriva. So without going into great detail, the platform supports a comprehensive set of capabilities for FAIR data. These include descriptive metadata, standard web services, extensive Python and R APIs, standard open authentication protocol. That means that most of you can log in with your institute credentials or even NIH credentials, data versioning, and history for everything. Not just files, but actually all the metadata records as well throughout the entire database are versioned, and we have history on all of them. And the whole platform adapts automatically around the FaceBase data model, even as it evolves. This is a unique characteristic of our platform to keep data as the central artifact of our system. And our ability in FaceBase to adapt and evolve to new requirements is based largely on our approach to, first of all, build a general purpose platform and then specialize it for DOC research. Another key factor in having that flexibility was not only the general purpose platform, but an approach to curation that engages the community itself. So rather than a throw it over the fence kind of model where the contributor will zip up some files and maybe include some spreadsheet with locally coded terms of their own that a repository curator then has to unpack and try to align to standard terms and a standard structure. Instead, in FaceBase, the community actually curates the data themselves. This is something that we call self-curation, and the curation environment system is FaceBase itself. So in other words, there's no secondary data submission system separate from FaceBase. It's almost like a Wikipedia for data, where the contributors are actually editing the site with a key distinction here that we have policy-based access control, we have quality control standards, so what goes out into FaceBase has been vetted by us. So now when you think back to the 5-year statistics about contributions, that's why we were really pleased, if not a bit relieved, that the community members were willing to continue to contribute and curate high quality data. And then another thing that we've been fortunate and able to do is that we've been able to support independent consortia efforts as well. So these are groups that have a consortium that is producing and collecting data, but we're able to serve as the data infrastructure. So they get to build on our established technical platform, our policies, our practices that have been refined over the past several years. 2 examples shown here. So on the left, we have enamel-based consortium of research projects that are producing new models and data on dental and enamel formation. And you can now find their data and information about their consortium on the FaceBase site. The second example is a newer consortium on the right-hand side called CranioRate that is collecting data on patients with metopic craniosynostosis and developing machine learning models of the syndrome for pre and post-operative patients. So by engaging with consortia like these, FaceBase has been able to provide a home for high-value, high-quality data, and the consortia get to leverage our infrastructure and our technical investment. So all of this, and it's great to see a version of the slide in Jennifer's talk as well. So all of this adds up to an approach that we sometimes call hybrid repository that sits between the specialist and the generalist repository approaches. So you may be familiar with those as well, but a specialist repository tends to be tailored to a specific type of data, animal model, et cetera, and has detailed descriptive data, but comes at a high cost in terms of the curation and the effort involved in creating that. And then on the other hand, on the right-hand side, you have generalist repositories, which have more of a do-it-yourself approach that expedites data sharing, but potentially at the cost of the quality and fairness of the data. So while FaceBase fulfills a role of a specialist repository for the DOC community, because of our flexible approach, we're able to fill the gaps left by generalist repositories. And, as FaceBase has expanded in scope from 1, 2 to 3 phases, and that mandate has grown, we've been able to accommodate and expand our platform as well for data that would have otherwise been left up to generalist repositories. Okay, so now I'm going to just briefly touch on a few highlights of recent accomplishments and activities. First of all, as we mentioned, the scope of FaceBase has grown from a narrow developmental focus to a broad and more diverse range of DOC research. Most recently, we have encouraged contributions of translational research data. In year 4, we worked with Dr. Marizita and her lab to integrate a first such data set from the Center for Oral Health in Appalachia, or CORA. So this data set actually touched on 2 NIH priorities, one being a more immediate impact on human health, and secondly, it addresses underserved populations. In the past year, CORA has released their complementary dental score data set as well, and we have now engaged with additional research teams and are in the process of contributing additional translational data. Of course, I want to assure everyone who's been part of our our FaceBase 1 and 2 focus that we will continue to be a home for primary research data on craniofacial development and malformation, but obviously it's important for us to embrace the whole DOC and related research, as so much of the science is connected and health is connected. Okay, FaceBase is now on the cloud 100%. This work was in part sponsored by the ODSS through a supplement for improving scientific software. Back 5 or so years ago, when we envisioned FaceBase 3, moving to the cloud was perhaps a bit too aggressive, the costs uncertain, but obviously as technical environments around us have developed considerably, has made the migration to the cloud a really key step in scaling and sustaining FaceBase infrastructure. This took a development effort of refactoring our underlying Deriva software to make sure it could properly utilize cloud-native services. In last year, we announced the launch of our public site and data infrastructure. And in this past year, we have migrated our data processing pipelines to the cloud, and also our human subject secure infrastructure is now on the cloud. So we're now fully in the cloud. We use the AWS through the NIH Strides and benefit from the Strides discounts. We're also working on further optimizing of our cloud storage to reduce costs. This too was enabled by an ODSS supplement. So one of the major factors for the ongoing sustainability of a data repository, not surprisingly, is to have efficient cost of our data storage services and efficiently handle any volume of data that the community can contribute. So we've enhanced our services that sit on top of cloud storage. I won't go into the technical details there, but it's allowed us to really enhance our, on the one hand, our internal development environment, staging environment, so that we can have essentially a mirror copy of FaceBase, that we can make sure that we are able to roll out changes to FaceBase really reliably and at a very low cost without duplicating the kind of data we have to store. But it's also setting the stage for something a little more ambitious about being able to federate in more third-party data resources and capabilities and work with more consortia efforts as well. Trust is another codified set of best practices. So trust stands for transparency, responsibility, user focus, sustainability, and technology. Whereas FAIR is a guideline for the data, trust is a set of guidelines for the data repository. So in the past couple of years, aided by another supplement, we strengthened a lot of our operating procedures and policies to bring them up to the standards of trust. This is another thing that didn't really, it didn't have the kind of traction 5 or so years ago that we would have envisioned at that time. We then, in the past year, we've applied for the Core Trust Seal certification, and our application is under review. So while, an NIH, NIDCR endorsement is most likely good enough for many contributors to have confidence in FaceBase, having an independent third-party review and certify our operating practices adds to the credibility and confidence, especially given our international audience, our international users. Okay, well, the next is the NIH's requirements for data management sharing plans for all new awards is obviously a very big step towards realizing the goal of high quality shared data, large volumes of data throughout the NIH. However, it does come with new challenges for researchers who must now comply with the MS policy. So there may be some uncertainty, if not confusion, for how to write an acceptable DMS plan or even plan for data management. So given our role as a data repository, we have invested our efforts in drafting documentation and templates and training material to help investigators to develop good DMS plans, especially those that would be compatible with FaceBase. Our aim is to help investigators plan successfully, not only to write a good DMS plan, but to be able to follow through with it and eventually realizing that sharing of data through FaceBase. Okay, in our final highlight here, we have made a concerted effort toward AI ML ready data, making our data AI ML ready. So meaning that we begin with a solid foundation of FAIR data principles, and then we apply those to the curation of very large data sets. So obviously, AI/ML algorithms are extremely data hungry. They need large data sets to make good predictions and classifications. They need data that are consistently labeled. Our efforts here were twofold. First, to reevaluate and recurate some of our older large data sets that have great value for machine learning, like our facial scans data. We identified gaps in some data sets, worked with the original contributors to acquire additional complementary data, such as data on additional syndromes. We also worked with members of our community to unify a lot of our genotype annotations, strains, gene nomenclature to better align with some of the controlled vocabulary. And we built out tools for importing and exporting of large data sets efficiently. Okay, so in this final section of the presentation, we have a few exciting proofs of concept and future plans that we'd like to share with you. And just to give a little disclaimer that these are early exploratory work. I'll go fairly quickly. You can, of course, find us throughout the day and in the poster session for more details on any of these. Okay, so again, clearly AI and machine learning have become areas of intense interest and activity in scientific research. But while impressive achievements like, say, AlphaFold indicate the potential for how AI and ML may transform scientific discovery, there are some serious pitfalls and often cited risks associated with ML and science. So things like data skew, biases in the model that are inherited from the skew, lack of transparency and how a model is trained, even failure even to properly validate a model performance with appropriate and documented splits between training, validation, and test data sets, and ultimately a scarcity of clean data for training models. So in our POC here, we're working toward reproducible machine learning pipelines with the integration of high quality data curation into the machine learning pipeline itself, so that you know exactly what data are used to train the model. You can have use of free and low cost Google Colab services, use of for-fee machine learning accelerated cloud resources, automatic generation of those training, validation, and test splits of the data, and cataloging of all operations to ensure reproducibility. The screenshot here on the upper right just shows one of our executable notebooks that is integrated with a FaceBase development environment with the ML capabilities. In the future, we'd like reproducible ML pipelines to be a capability that's available and tightly integrated with FaceBase. All right, the 2023 public release of ChatGPT has made AI a household term, but it really has, we have seen intelligent assistants becoming more common in our lives and the software that we use. So these are based on a type of ML that's called a large language model, LLM. And while LLMs can generate plausible sounding text, and indeed they can perform remarkably on a range of natural language tasks, they are prone to biases, errors, and what are called hallucinations, meaning that they generate output that is not necessarily grounded in reality. The key to using LLMs effectively is to ground them in facts. One of the current best practices for doing so is called retrieval augmented generation, or RAG. So in this POC, using the RAG method, we created a vector database from FaceBase metadata. We implemented a pretty standard semantic search to retrieve fuzzy matches over that database, given an input sentence. And then we use that semantically relevant results to feed in and contextualize the LLM results. The screenshots here on the left and right show the performance of ChatGPT 3.5, unmodified on the left, and then contextualized with FaceBase on the right. And in this example, we posed a question about a rare disease. So on the left, we get back what appears to be a sensible answer. However, you'll note we kind of highlighted it here on the right, that the contextualized answer is enhanced with mention of its connection to craniofacial impact and disease. So on the left, there's really no mention of that. And then also, secondly, we are able to extend the answer with excerpts directly from FaceBase. So again, this is only early stage work done with very limited resources, but already kind of promising direction to explore further. All right, another POC we explored was to extend FaceBase to support audiograms. As it turns out, so there are machine learning libraries, open source software available that can visually analyze the clinical audiogram document to a certain extent, extract data points from the audiogram and extract metadata from the rest of the document. And in this POC, we extended the FaceBase database schema to support audiogram metadata and non-PHI clinical encounter information, storage of the clinical audiogram documents. Those are like, would come to us in a PDF format, and then using the pipeline extraction of audiogram data points using that open source ML code, and then used our own integrated visualization capability as part of our Deriva platform to display the extracted data for the audiogram online. You can see an example of that, the original record on the far right in 2, and then the extracted and visualized form in 3, and above it, additional metadata. So this example shows also how our approach with FaceBase to build a generalizable infrastructure and then specialize it allows us to rapidly extend to new types of research and support new communities. And then along the similar lines here, so this is sort of I would say a FaceBase adjacent POC in a parallel project here, using the underlying Deriva platform to manage data for an AI project with iData. So this supports multiple data types such as fundus and OCT and relevant clinical elements and other types, and ICD-10 information as well. And it's being used currently to develop explainable machine learning models to determine the potential for glaucoma. Okay, now looking ahead to what we envision for the next 5 years of FaceBase. First of all, we will continue to be a home for developmental craniofacial research while expanding to all DOC and related data across the translational spectrum as determined by our steering committee and advisors. Secondly, to enhance their computational capabilities of FaceBase, so more integration of conventional genomics and imaging pipelines, increase in online visualization of more data, and then also development of those reproducible, robust AI/ML pipelines and related tools to support the community, as well as federation with other data resources. So there are, of course, other valuable resources like Terra and Galaxy, as well as the more AI-focused ones like Google Colab and others. And we envision FaceBase federating with a broad ecosystem of data resources. Thirdly, adding in more educational and training resources, example of compute notebooks, code recipes, things to help jumpstart one's research and analysis using FaceBase data. Of course, additional support for DMS plans, helping our investigators assess and validate DMS plans. Fourth here, moving toward what we would call full data lifecycle support. So currently, sharing is sort of the last step. We'd like to be able to host more communities even before they're ready to share data. And so that kind of goes back to some of the optimization we're doing on our cloud platform, and just be able to support individual investigators as well with managing and organizing their data that is pre-released to make it easier for them to share it in the end with the community. And then finally, of course, ongoing enhancements to our trust and fair data handling practices. Okay, and with that, I thank you for your time and your attention, and most of all, would like to acknowledge the FaceBase team, our scientific advisors, the NIDCR leadership, and their close collaboration with us, and of course, our sponsorship from the NIDCR and ODSS. Thank you.
Any questions? And remember to touch the person talking icon on your table mic. And everybody on Zoom, feel free to add your question in the chat.
Yeah, Pedro.
I had a question. The audiograms was really nice. I really liked how it's actually real data from the patient. Are you planning to get serial data, or is there any way to extract that from the medical records, like they would release or consent, and then we get the actual data from the institution directly?
So question is, will we extract additional data from the health records associated with it?
So certain syndromes have like late onset hearing loss or progression of hearing loss. And so it's just nice to know pre-surgery, if they have craniosynostosis, if they had no hearing loss, and post-surgery, it became conductive on the left side.
Yeah, we're definitely looking at, in general in FaceBase, in integrating more health records as a source of data into FaceBase. That's also pretty early stage, but it's something that we've been having more conversations with other investigators who could kind of help and collaborate on that. I think the general answer is yes. I think we're exploring things that would be complementary to that. And any other questions? Yeah. Okay. So, yeah.
Yeah, thank you for that overview. So my question is, can you elaborate or speculate on the potential of the FaceBase chatbot exploratory activities in the context of benefiting the research community, but maybe some challenges with bioethics? Would it become a source of, guidance for a general public? I mean, would people go in and say, hey, I have this mutation, what do you think? Would it generate answers to that kind of questions?
The current POC could generate answers like that because it's built on top of the OpenAI's APIs for the ChatGPT 3.5. So I think we're still very early stage with that, and that's a very good question about the ethical considerations of it and the limitations of it. So there's often times when you encounter these these chatbots right now, what you typically see are disclaimers on like, don't use this for, and I think we would certainly want to have that as well. Our primary focus has been on helping someone find their way to interesting things in FaceBase. And what we'd like to do is sort of limit the scope of the kind of answers. So is all of that possible? That's something that we'll explore. There's a certain amount of things you can do. It's like, this is contextualizing these large language models and prompt engineering so that you're kind of guiding the types of answers. So those are things that we'll be exploring. It would be, we kind of see it. I don't know if Carl has anything to chime in, but I think we'd like to see how we could exploit and surface more of the FaceBase data through that so that we could give a more tailored FaceBase answer and guidance to data that's in FaceBase. Like, help me find data on this syndrome in FaceBase, for example, would be a great, tool. And I think also that as I've heard this from people who work in the search, industry that even just conventional search the expectations for conventional search have really been changed by the chat interfaces, that people are kind of expecting a certain amount of memory in a search experience. So I think this is going to affect how all of us provide information retrieval tools, and something that we ought to be exploring early. Yeah.
I think one thing, we shouldn't overplay what we did. It was very, very straightforward and simple. It was just an exploration, but it was quite interesting that if you ask this particular syndrome to ChatGPT 3 and 4, you got an answer, right? The difference is when we used the RAG augmentation with FaceBase, we got an answer that was customized to the craniofacial ramifications of the syndrome. So I thought that was quite interesting in that we we took what you would get back by asking that question to ChatGPT right now, and got back additional information that was specific to the craniofacial aspects of that. So I think that kind of, again, it's very early, but it indicates that you could really increase the power and impact of something like FaceBase by making ChatGPT smart about all the craniofacial stuff, which it basically doesn't know right now. And then you tie that to other things like there are people building repositories of PubMed and bioRxiv and so on. So you can imagine how we start to stitch together this information and then specialize it with what we know about craniofacial and DOC, which nobody else has. So then it becomes a really interesting resource, I think.
So for time, this might be the last question, but I have a question from chat from Dirk Jooster, who is part of the enamel-based resource that we've worked with him on FaceBase. His question is, can you tell us a bit more about how you envision storage of large visual data and HPC may be integrated in the future? I'm particularly interested in how compute resources would be paid for.
Yeah, so that sounds like kind of two-part question. One on how we envision the federation of storage, and then the compute side of it. So in terms of storage, there's so one of the federation capabilities is that we can actually, we're really close to being able to stitch in other data storage into FaceBase, into Deriva, and just kind of plug in. So in AWS, in cloud terms, the object stores, they call them buckets. So you could bring your own bucket, pay for your own bucket, and bring that in and federate it into FaceBase. So like, let's say there's a consortium that's doing, that's generating data, wants to utilize the FaceBase infrastructure, but has kind of private resources. We could actually accommodate that, and the consortium could pay their own storage. Obviously, anything that's shared publicly through FaceBase is done freely. You don't pay anything to put things publicly in FaceBase. But we see that as an opportunity to be able to stitch in underlying storage resources. And then on the compute side, I don't think there's any talk right now of us or thoughts of us providing all computation capabilities. It's more the federation, because obviously that comes with a huge cost that we couldn't contain. What I mentioned are Google Colab, which is it's free. It's a freemium model, so you can start off free and actually do a little bit of learning of AI kind of techniques. I think Terra, I believe, starts off free, if I'm not mistaken. So there are some resources that are available that one could use. And so what we want to do is improve our interfaces to make it really simple. We already have working examples, but make it super simple for somebody to use one of those resources and connect to FaceBase data. So paying for the computation is, an exercise for the reader, so to speak. But we want to make it really simple to be able to either bring storage resources into FaceBase that obviously there's a certain amount that are provided by us for any public data, but actually bring in non-trivial large data into FaceBase that could be paid, out of a consortium paid bucket, so to speak. And then on the compute side, as I'm saying, be able to provide really streamlined access to these cloud hosted and other resources that are out there. And they have, I know Terra has some model where you can pay for yourself, your own computation. HPC resources, we do have, and I should hand over here in a sec, but it's a big question. So for HPC resources, we do have APIs for everything you can do in FaceBase. We have the open authentication protocols. We have command line tools that are available on Linux. So most HPC environments will be running on Linux operating systems. We have tools for all of that, which can do the bulk download and upload of data, does integrity checks, does retry. It actually does multiple streams of upload. So it's like when you upload a file, it'll actually send it in multiple streams to maximize the use of your bandwidth if you have a really fast pipe network. So we have a lot of those optimizations that are already available. Okay, thanks. I see that.